Welcome to the Chapter 6 Microlecture. This microlecture is broken up into two parts. For the Internet, WAN, LAN, sort of connectivity pieces, please watch the Warriors of the .NET video, which is also included in the chapter folder. Chapter 6, Microlecture, will talk about just the things that aren't in Warriors of the .NET. Let's talk real quick about the IEEE. IEEE is the Institute for Electrical and Electronics Engineers. That's a geeky group. They create all of the standards and all of the protocols, whether it's wired, wireless, Bluetooth. They create the standard. They create a vendor agnostic standard or protocol so that all the vendors in the world can talk at the same language. When you're looking at wireless, there's a couple of sort of major things. We're all learning now about 3G and 4G, and WiMAX is a type of standard. It's a standard that's an alternate for cable or DSL, and it's going to be a wireless high speed. It's similar to what Sprint is selling today as 4G. When you look at how you'll connect your personal computer to the internet, there's three major ways. There's dial-up modems, and there aren't many left. There's DSL modems, and there's cable modems. A modem is actually a modulation device, and that's part of that squeaky noise you used to hear when you had the dial-up modem. Narrowband is considered less than 56K, which was the dial-up limit, and broadband was considered more than 256K. If you want, go to speakeasy.net, and they have a free speed test, and you can see what your speed is today. So when we look at our personal computer, you can see that we have the personal computer, the modem, a switch at the network and telephone operator, and then our internet service provider. And all of that's going to connect us to the internet. DSL modems are probably the most popular type of high-speed internet. They operate over phone lines, and they offer significantly faster transmission than dial-up. They also use their own protocols. Now there's two types of DSL. There's ADSL and SDSL. Typically we're all running ADSL at our house. Cable modems provide even higher speed access. They use a coaxial cable or a fiber cable to run into a network station. Now the biggest difference here is that about 500 subscribers can connect to each substation, and every subscriber divides the total number of bandwidth by the total number of subscribers. So in short, if you have a cable modem, tell everybody in your neighborhood you hate it. It'll ensure that you get the fastest speed because they'll go and get DSL. The public switch data network is really the name for a network of computer and leased lines. It's developed and maintained by a vendor. Let's say we're at Aetna or we're at Cigna, and we have a bunch of buildings, and we don't own the space to run actual wires on telephone poles to go back and forth. What we would do is go to a public switch data network and pay for access on a grid. And we would actually lease access in something called a point of presence. If you looked at this, you would see that these point of presences can be worldwide. So we can have a Chicago site, a Denver site, and an Atlanta site, and they can all get access into the PSDN in the middle. And through that PSDN, all of these sites will be able to access each other. PSDN operates on three major protocols: frame relay, which was the most common, probably for low-end connectivity. On average, your T1 line is going to be in a frame relay. It's simple, it's easy. ATM is a very fast type of signal. It really didn't get great adoption because it was a lot different than Ethernet, which is our third type. And once most network engineers understood Ethernet, they didn't want to learn a whole second separate ATM language just to do the same thing. So they standardized on Ethernet. When we want to compare WANs, often we look at cost, performance, and growth potential or management time or technical. But generally we want to look at what's the cost and what's the performance, what's our speed. So this is a nice grid that helps us look at what the total cost of ownership might be when we're comparing wide area networks. Now, the final part of the chapter talks a little bit about encryption and security and firewalls. So basically encryption is a way of transforming clear text into coded text. If you are going to interact with your bank, you hopefully are going to have an HTTPS secure connection, and that's going to use a type of algorithm to encrypt your transmission so that no one else can take your account number, bank number, or hopefully your money. There are many types of encryptions, DES, triple DES, advanced encryption standard. You'll find these on both wired connections and in wireless. Generally, these use keys to encrypt data. You have a key and someone else has a key, and you use those keys to encrypt and decrypt that information. So there's symmetric encryption, in which the same key encrypts and decrypts, and asymmetric encryption, where different keys are used. There's also something called private-public key cryptography, and that means that we send a public key to another party so that they can encode messages for us, and we decode them with our private key. It's very complex and it's very slow, but remember, computers often measure speed in nanoseconds, so it's really not that slow. The most popular type of security is the HTTPS, or Secure Socket Layer. That's fast, it's secure, and we'll show you how it works. A firewall is a device that's going to prevent unauthorized network access. Often the firewall sits in between the internet connection, or the router, and the inside of the network, or the private network. Perimeter firewalls sit outside the network, and internal firewalls sit inside the network. Internal firewalls are needed when you have specific data that you want to have a second level of protection against. The CCSU banner database might be a good example of something that's inside another firewall. And that's to protect it against threats from inside the network, like from the student dorms. One way to make sure that only certain people get into certain resources is to create an ACL, or access control list. And that's going to be a static list that says that this name or this IP address is authorized to connect to this device. A VPN is a virtual private network. Often we see this in work-at-home uses, where people will be at home and they'll want to create a secure and encrypted tunnel to the inside of their corporate network, and this will allow them to do work and exchange information in a protected way. That's the end. Have a great day.